Hiya 10. I just thought I'd do a video really to explain a little bit more about the case study that you're supposed to be doing for geography. So this case study is the Holderness Coast, and the learning objective for yesterday's lesson and today's lesson is to understand the reasons why the Holderness Coast is the fastest eroding coastline in Europe, and to also investigate some of the factors that affect the rate of erosion and some of the coastal management that's taken place. So I thought to start with, because obviously I would usually draw this on the whiteboard in my classroom, I'd introduce you. When we do a case study, we always have to know where the place is, so the location section. So this is my lovely diagram of the UK, okay, so you can see my classic two triangles that I normally draw in class. And so Sidmouth is down here in the southwest, and the Holderness Coast is on the northeast coast of England, so it's in Yorkshire. Some facts about it that you might have picked up yesterday from the video is it's the fastest eroding coastline in Europe, and it's 65 miles long from north to south. So here's a diagram of the Holderness Coast. So if you look at this diagram, you'll see you've got Flamborough Head up here in the north, and Flamborough Head is made up of chalk, which is a relatively resistant rock type. And then going down, you come to the bottom here, which is Spurn Point, which is a sand spit. Usually when I say Spurn Point in class, everyone laughs. It's Spurn Point, S-P-U-R-N, not Sperm Point. And basically the sand spit has formed across the mouth of the River Humber here. Okay, so why is this stretch of coastline eroding more quickly than anywhere else in Europe? Hopefully you have found out some of the reasons for this while watching the videos and making notes yesterday. But these are the main reasons, okay? So I'm going to talk a little bit about these reasons to you. So one of the reasons is geology and the rock type, which we'll talk about. One is fetch. So fetch is the distance of ocean that the waves travel, that the wind blows before it reaches land. So the bigger the fetch, usually the bigger the waves. Longshore drift, and the fact that the beaches on the Holderness Coast are really narrow, and the sea, the North Sea, is really deep. So all of those factors affect how quickly the Holderness Coast is eroding. So we start first of all here with geology. So first of all, Holderness Coast is technically a discordant coast because you've got chalk and then you've got boulder clay. So the chalk forms a headland at Flamborough Head, and at Flamborough Head, if you do some research on the website, which I've put on Show My Homework, you'll see that Flamborough Head has the classic cave arch stack formation. So you can do a bit of revision of that as well, about how that's created here at Flamborough Head by the process of erosion. And then further south you've got boulder clay, which is like a really, really soft, unconsolidated rock. So it's a little bit like the mud in my garden, although this is really dry at the moment because we've had such nice weather. It's really crumbly. So boulder clay is just really, really crumbly like this, and you imagine water mixing with that, it just goes to mush. So boulder clay is like one of the softest rocks. Now, the reason for this geology links back, so a bit of interleaving back to the stuff you did about glaciation at the beginning of this topic. So at the end of the last ice age, the north, if I go back to this, the north of the UK was covered in ice. Okay, so at the last ice age, north of the UK was covered in ice, and the boundary was around about the Holderness Coast. So when this area was glaciated, and remember glaciers are like frozen rivers, those rivers would have come down and plucked away at the land. So they would have picked up sediment, bits of mud, bits of rock, stones and so on from the land. And then at the end of the last ice age, when the ice melted, all of that sediment, so all of this stuff that the glaciers had picked up, was deposited. And it was deposited actually on the Holderness Coast. So the boulder clay that exists basically is the remnants of sediment carried by glaciers during the last ice age. So it's really unconsolidated, it's very young rock, and as a result it's one of the least resistant and fastest eroding rock types anywhere. In fact, since Roman times, this stretch of coastline has lost 29 settlements, so 29 villages, towns, etc. to the sea. They've just crumbled and fallen into the sea. And you can research more about that if you want to. So that's one of the big reasons, the geology is one of the big reasons why this coastline's eroding so rapidly. On average, it's eroding 2 metres a year. So if you imagine 2 metres from your garden, if you've got a garden, 2 metres a year is loads. My garden would be disappeared in like 3 years if my garden was eroding that quickly. So 2 metres a year on average is massive. But actually some parts of the Holderness Coast have reported losing 20 metres in 1 year. So 20 metres is a huge, huge amount. And to sort of see how big that is, when you're out on your next daily exercise, just pace 20, and that's how much land some of the people along the Holderness Coast are losing each year. So the big factor is geology, and that's something that you might want to do a little bit more reading about to understand, but that's one of the big factors. The other big factor is the fetch. So the fetch, I haven't got a very good diagram of this, but basically, if you went across the North Sea, you would eventually hit places like Norway, okay? And it's about 500, 600, in some places 800 miles before you hit land. So that's a relatively large fetch. The longer the fetch, the longer the stretch of ocean before it reaches the land, the more powerful the waves can be. And obviously, the more powerful the waves, the more destructive the waves are, so remember destructive waves, and therefore they have a bigger backwash and they remove more sediment. Okay, so the fetch being quite big has an impact on how quickly this coastline's eroding. One of the other factors is longshore drift. So longshore drift happens from north to south along this stretch of coastline. Okay, so sediment is picked up here and dragged back into the sea, and then it's moved by longshore drift diagonally down the coast and eventually deposited in the south at Spurn Point, which is this sand spit, and we'll learn a little bit more about sand spits in a future lesson. So the sediment moves down the coast and it gets deposited here. The reason that Spurn Point doesn't reach